Hey, welcome back to Common Core Algebra II. Today's lesson is 10.3, Rational Expressions, Multiplying and Dividing. So just like we did in yesterday's lesson in 10.2, we talked about simplifying rational expressions without multiplying. This is just the same process, just a little bit longer. So in exercise 1, it says simplify each of the following rational expressions by factoring completely. For the numerical fraction, make sure you prime factor all numerators and denominators. And as you get good at this, you'll just be able to cross cancel. All right, so what they mean by that in letter A, 6 can be rewritten as the primes 2 times 3. 8 can be rewritten as 2 times 2 times 2, because those are your factors. 10 can be rewritten as 2 times 5, and 3 is simply 3 because it is already a prime. So we can cancel up and down, we can cancel diagonally, we cannot cancel side to side. So in other words, I can cancel these two, I can cancel these 3, and I can cancel these 2. So what's left over? In my numerator, I have a 5. In my denominator, I have a 2. All right, so make sense of that. And we will move on to a true rational expression in letter B. All right, so we're going to do the same thing. So when we have rational expressions, we are simply going to factor the numerators and the denominators just like we did with the numbers on letter A. So hopefully we're going to start right here at x squared minus 4, which is the difference of two perfect squares, x minus 2, x plus 2. Hopefully that red flag goes up for you. In the denominator, again, you're going to have the product of two binomials, and you should be able to factor this fairly easily. When you have a leading coefficient that is a 1, you can simply read it backwards. What are the factors of 6 that are going to subtract to give me negative 1 right here? That 1's hiding. So the answer here is going to be negative 3 and positive 2. Now I assume you might have to take a few extra moments to come up with those. And if you look on the right-hand side, those are not going to be products of binomials. You're just going to look for a GCF here. So what goes into, so I'm right here looking at the numerator. So at 3x squared plus 15x, I'm going to pull out a 3 and an x. And then what do I have left over? I have an x plus 5. That's dividing each of them by the 3x. And now I'm going to work on this denominator right here. And I'm going to take out a 6x. And again, I'm going to have an x minus 2 left over when I'm all said and done. So now this is the fun part. This is when you get to cross things out. And you should be able to. If you get to this point and there's nothing to cross out, then you made mistakes. So the first thing I see is this x minus 2 and this x minus 2. I see no x plus 5, but I have an x plus 2 here and an x plus 2 here. I can't do anything with the x minus 3 in the denominator and the x plus 5 in the numerator, but if you take a look right here, I can cancel out these x's, and I can cancel this out, and I have a 2 left over. Now you could rewrite the 6 as 2 times 3, but it's just as easy to see 3 goes into 3 once, 3 goes into 6 twice. So now this is where you have to be very careful. Make sure you remember everything up in the denominator. So the only thing left there is x plus 5. And then what do I have in the denominator? I have x minus 3. And then I have that 2. So I'm going to put the 2 out front because that's generally where we put our coefficients. All right, now, if this is now remember, that's not a squared here. I don't want you to think that. If this is a multiple choice question, another possibility for an answer might be x plus 5, and they may distribute this and get 2x minus 6. So it could be one or the other. You would get full credit for either one if it was a constructive response. So write down what you need to, rewind, pause, and I will meet you at exercise 2. Okay, simplify each of the following products. So we're going to start here with a little bit easier ones than the one that we just did. So we have 8y to the 7th over 5x to the 3rd. So sometimes I think the easiest thing to do here is multiply straight across. So if you multiply straight across here, now you could cross cancel like we did in the first problem, or you can follow the Roos multiplication. So if I multiply straight across, 8 times 10 is 80. I have x squared, I put them in alphabetical order, y to the 7th, because it's easier to see them that way. And the bottom, in the denominator, I have 30, 5 times 6 is 30, x to the 3rd, y to the 3rd. And now just follow your rules for exponents. We're going to reduce the 80 over 30, just divide by 10, and we get 8 over 3. Oh, you know something, let's just do it this way first. 8 over 3. And then subtract 2, the x's. 2 take away 3 is -1. 7 take away 3 is 4. So you can write it like this. Again, if it's multiple choice, it might tell you that the y stays up in the numerator, but the negative exponent for the x drops into the denominator and becomes positive. Okay, so either one of those would be an acceptable answer. We're looking at B now, and you can do this the same way we just did A. Multiply straight across your numerator. So we get 60, x, remember this is x to the 1st, so we have x to the 3rd, y to the 5th. With me so far? Okay, so 4 times 9 in my denominator is 36, x to the 10th, y to the 9th, just added my exponents. And now we're going to simplify. So what number goes into 60 and 36 evenly? Well, we can reduce both of them by 12. So you could reduce by 2 and then reduce by 2 and reduce by 2. So you can keep doing things like that. Or you can simply realize that 12 goes into 65 times and into 36 3 times. So I have 5 over 3. And again, I'm just going to do my subtraction. Of my x's, I'm going to do 3 minus 10, which is a -7. I'm going to do 5 minus 9, which is a -4. And what does that do? It moves the x's and y's into the denominator. So 3, x to the 7th, y to the 4th. Either one of those would be acceptable. Going on to C and D. These are the ones that get a little bit harder. But as you get better at factoring, you'll see how these get a little bit easier. All right, so what we're going to do now is we're multiplying straight across. So the first thing I'm going to look at is my fraction on the left, and I can see that I can pull out a 2x out of this. Can't factor this. We don't have that trinomial here. So what do we have left over? We have x plus 6. In my denominator, I take out a 4, and I'm left with x plus 2. The fraction on the right has to be factored into 2 binomials. Because it has a leading coefficient of 1, it's not too bad. I know my signs are different, so one is plus and one is minus. And I know the two numbers multiply to 12 but subtract to give me 4. So if you need to come over here and say 12 is 1 times 12, 2 times 6, and 3 times 4, which ones subtract to give me 4? It's these two right here. And I need it to be a -4, so the 6 gets the negative, and the, whoops, I put 4, I had to, why did I want to do that? This is a 2. All right. So I do a quick check, -6, +2, -4, that's fine. And then in the bottom, hopefully those red flags are flying, and you can see that that's the difference of two perfect squares, x minus 6 and x plus 6. So now this is the fun part. All right, so what are we going to be canceling out? We're going to cancel out this x plus 6 with this x plus 6, this x plus 2 and this x plus 2. Wow, cool beans. Look at that. There are the x minus 6's. They go out. And what am I left with here? 2 goes in once and into 4 twice. So my final answer is going to be x. Don't forget about the x there. That's why you have to be really careful. So here we have an x over, because here's my x right here. X over 2 is my final answer. I impeded a little bit on my letter D here, so I'm going to slide this up so I have a little more room. And we're going to do the same thing with D. So if you need to pause that and write everything down, do that now, and then we'll get to D. All right, so moving on to D. So we're going to move on. We're going to look at the left fraction first. And as you can see, again, difference of perfect squares and order counts. So 3 minus x, 3 plus x up in the numerator. In my denominator, I can pull out a 2 because 2 goes into 2 and into 6. And I have 2 x's, so I can take out an x squared. And then what am I left with? 1x minus 3. All right, let's move to the right-hand side. I'm going to factor out a 4x, and then what do I have left over? X minus 1. Remember, it's like dividing each of these by 4x. And our denominator is going to be 2 binomials. X, I know my signs are different because that sign in front of the 3 is negative. So I'm looking for 2 numbers that multiply to 3 but subtract to give me positive 2. And it's positive 3 and negative 1. And at this point now we're going to be doing some canceling. So I see that I have an x plus 3 here, and I have a 3 plus x, which is the same thing. We talked about this in a previous lesson, how that's just the commutative property. All right? And now you see that I have 3 minus x here, and I have x minus 3 here. So if you remember this, they do cancel, but by multiplying one of them by a negative 1. Oh, here's x minus 1s. They can cancel out. Here I have a 2 and a 4, so 2 goes into 4 twice. And then I have 2 x's down here, but I have an x left over, and then I have an x over here. So what's left in my numerator? Just a negative 2. Everything else canceled out. And what's left in the denominator? Just an x. That's the hardest part, actually making sure that you are writing down what's left over properly. So it's really important to make sure that you're organized and neat when you're doing these, because if you're not, you can be making some silly mistakes. All right, if you do not have enough paper, my advice is do it on line paper or just plain copy paper. It'll make things a whole lot easier for you. So division, we're going to move on to exercise number 3 now. Division is almost the same exact process, except if you remember from middle school, sometimes you remember your teachers telling you say, change, flip when we talked about dividing fractions. So what they meant by that is the first one stays the same. The sign changes to multiplication, and the second one flips. 2y to the 7th over 5x to the 8th. And then you're just going to follow the same exact rules that we did prior to this when we did multiplication. All right? So why don't you pause this, try this on your own, and then we'll come up back with the answers. So there's the first one. So as you can see in A, when I finished factoring, I actually had 3's left here because I missed them. And that's okay. Because what I realized is that even if you miss something, you can still take another moment and factor again. Simplify again. So the 3's cancel out, and we're simply left with the y squared over x to the 6th. All right, so there's nothing wrong with that. Don't feel like you have to always do everything on the first step. So let's try and do the same thing for B. Again, just reminding you that when you're dividing, the first one stays the same. The sign changes, and the second fraction flips, or mathematically, we take the reciprocal of it, and then we simply multiply it. So that one, I think we can probably factor this. And again, you don't have to always come up with the right things on the first try. So I can see I can divide by 10 here. So I'm going to have, so you might say, well, I've got 3y to the 6th over 2x to the 3rd times. Now 8 over 24 reduces to 1 over 3. So I get 1x over 3y squared. And now you can see, well, I can cancel out these 3's. And I have x cubed. Oh, why do I, that's not a 3. Sorry. I didn't want you. I have x cubed down here. I have an x. This one cancels, and I have an x squared left. This y squared cancels with this y to the 6th, and I have y to the 4th left. So beware. Like I said, if you're not neat, it gets a little confusing. So across the top, I have y to the 4th. And across the bottom, I have 2x squared. And that's your final answer. I actually think they're harder to do than the ones like C and D where you have to factor them, because I think it's easier to lose the x and the y's in the translation. So let's do the same thing on C and D. Why don't you try them on your own, and then we'll come back with the answers. All right. Ready, set, go. So there are the answers. Beware of the way they can be represented. Down at the bottom, if it's multiple choice, either of those could be represented, and the same thing when the red on the bottom of D. Either one, all three of those are possible answers, but if you wrote down any of them, you would get full credit if it was a constructive response. So there's only one more to do, and that's exercise 4. Pause it if you need to write things down before we move on. All right, so it says when x squared minus 25, so basically it goes in order. X squared minus 25 over 3x is divided by, so is divided by x plus 5 over 9x. The result is, well, we're going to remember right away. Now you might start getting good at this and saying, well, let's do some factoring while we're flipping, because I know this is the difference of two perfect squares. I know I have to change this to times and flip this to 9x in my numerator and x plus 5 in the denominator. I'm going to remind you that when that x plus 5 is alone, you're going to put parentheses around it to protect it. And when they're exactly the same, that's when they cancel. So the 3 goes in once, goes in 3, and then these x's cancel all together. So my final answer is going to be 3 times x minus 5. Now, some people might say over nothing, but technically it's over 1. So that's going to be our final answer. But if I look there, I do not see that answer. And once again, it's just represented a little bit different. It distributes this. And once you distribute it, you come out with answer choice number 2. All right, so try to keep it under 20 minutes. I know this was a long one, but we'll see you again tomorrow, hopefully tomorrow. And until next time, make good choices.